I like to continue with Mr. Pfitzner, who is also leading the task force police in CANopen automation, and he will provide us with the viewpoint of the authorities with regard to CiA 447.
Gentlemen, my presentation should give you an overview over the police requirements of a network vehicle that has a specified vehicle network. The previous approach of a CiA 447 network comes into play here. I have divided my presentation into 4 seconds. At the beginning, I would like to present you my big picture on the topic again. Building on this, I present you requirements from the police point of view, which I would then like to consider from the security point of view. My big picture is a view of the environment of a modern vehicle, which parties are involved, which requirements are based on them from our point of view. Here in the middle, you saw topical of a modern automotive system, and we have different parties to play or become debtors and play with something on the car. At first, the forensic type or the diagnostic type. The second, the user or the owner. They are different in the point of view of our interests. And the online and offline discussion are there. The OEM have some point of view, the service provider and the infrastructure and other communication types which look at the data from the car. And the last, you see the police requirements. The police requirements perspective extends to essential characteristics of police works. At first, the preventive action. The second, repressive measures, forensic measures, resourcements, and traffic police considerations. It is important to define and process these requirements as use cases. One point we want to look at here is the procurement, especially the equipment of the police vehicle with the necessary requirements and interfaces for a modern motor vehicle. In elementary perspective is IT security and the functional safety of the resource. The following 2 slides are intended to show you 2 structures for networking vehicles. I would make a raw distinction when looking at the security concept and the expanded requirements for online networked vehicles. The network structure was initially shaped by the definition of the distributed function. Complex function can be implemented by controller device clusters, which can be distributed over the entire network. The security perspective was only considered to limited extent. The necessary processes were simply structure. The gateway generally represented a kind of news distributor. Look there, the security protection. There's a very simple, when you go to diagnostic and frame from a CAN communication, it's not so heavy. Modern automotive networks are structurally divided into domains. In addition, the gateway also has function tasks. Example are intrusion detection and diagnostic function, which become much more function and priority than the first. With the introduction of backbone networks, the domains are also networked with a fast bus system. Within the individual domains, master control devices managed various functionalities, including extensive automotive IT security measures. At this point of view, you saw very different security others. Looks like the firewall, looks like logic security zone, security boats, and this domain structure you see in the field by Daimler. Looks like the star 3 2.0 structure, or by Volkswagen now. This slide, you can see, on this slide you show the new structure of the vehicle network are more details. The point of view do you see here is the most security and the key access to manage this in modern art. At the middle, the central gateway have the function and the difference are connectivity gateways and so on. The problem for the police side is how do you become information about the network? You look there, you need to compare network systems, you need the plane of the network, you need network overviews, and you need description networks. The evolution of the IT system must be based on clear rules and processes. However, this assumes that all relevant documents are available for the assessment of the system. You need detailed knowledge to give a clear assessment. Unfortunately, there is no transparency on the field of the vehicle technology. You are in the rule of a supplicant. The system presents itself as a black box. Therefore, only a restricted assessment of this system is possible. At the next one, I will show you the requirements from our side. It's very simple. Our requirements, we would to become different data, or we would take a function on the car, and we have the build in our 47 group different standards to become this one. At the left side, you see different status or levels which we will become. The central locking system or different others. At the powertrain, we want to become the tank starters, engine status, and so on. And in order to be able to operate standardized specialized technology in the vehicle, a special vehicle network was developed. This standardization according the CiA 447 standard based on CANopen. And this one, we will see network according to the difference of standard-based CANopen. This ensures that manufacturer-independent components can be installed. A network connection to the vehicle network was implemented using a gateway. This ensures function safety. Due to different special applications, the gateway were defined into different classes. You look there, with our point of view of the BOS vehicle gateway, and we have defined different functions there. This slide should give you a little insight into the structure and the scope of the CANopen network. One point of view, you look at the OC layer layer discussion. You can the layer 1 and layer 2 and different layer at the over. And this one you show different protocols and profiles we used. Ensuring the IT security is a core element of self-protection for authorities with security tasks. From the point of view of the authorities, the requirements of the Federal Office for Information Security are binding. However, industrial developments are carried out, assessed and certified according of other standards. It is therefore essential to compare and coordinate the very different regulation. You look at the left side, the BSE baseline protection, and the right side as the ISO 21434 will be done at the VDR, and we have the difference between both documents. The BSE has produced a different basic protection module for company vehicles. Both regulations have one thing of common. They often do not provide and specify requirements for implementing the protection goals. The developer is given guidelines in which he must implement his solution. In the development of control units, the automotive market, little attention has been paid to IT security. Only with online networking did the vehicle become a real target for hackers. It is therefore important and urgent to consider the requirements of IT security and functional safety in the development steps. The picture shows such a process. It can be seen how the various approaches to be defined and implemented. Only a joint consideration of the protection goals enable a cost and security optimized development. Regardless of the various solutions for secure vehicle networks, two crucial questions arise. Do the approach guarantee real protection regardless of how is the generating the network access to the SPI IFN, and who is the master of the produce? The requirements present are intended to clarify the questions somewhat. However, one thing should be noted. Network separation can only be an option to guarantee security to a limited extent. A technical approach must therefore be found in order to continue to obtain information directly from the vehicle network and the securely access function of the vehicle. In order to achieve the state protection goal, it is necessary to take further protection measures. Here, too, the reference to holistic view of the topic is security is imperative. A system is only secure to the extent that all perspectives are taken into account, a view over the entire life cycle. I would like to introduce you two options for increased IT security in SPN I4N networks. Here, an integration of security hardware component. Olaf, in the presentation before mine, show us the possibility for different things. You look there. We cut off the network for the communication about the gateway to the CANopen CiA network. So we must put in a security firewall for different things. The firewall can, based on a dual core system, and we communicate in the core for property protocol, which is because of very security thing. An internal bus is an identification system. We can build a whitelist system, a plausibility check, and other functions that we can put into. Olaf has shown before, you can put only with, you can communicate only with I/O functions and different ways. At the right side, you go into the SPN I4N. It isn't not really important is the master implemented and this one out of firewall or in a other MCU, it is integrated into the network. Here's the second option, integrated of a CANcrypt software variant. However, I would like to refer to Mr. Olaf Pfeiffer, who has developed a concept for this. The basis expansion to the protocols with additional security algorithms, but we can ask Olaf in the discussion how he has developed this one. Finally, I would like to point at our Federal Office of Information Security has already given an initial indication of the development of secure SPN IFON. You can build it on the recommendation. The question, however, remains, will it still be possible in the future to develop and operate special vehicle at lowest cost? That's a question. Let's discuss that. Thank you for your attention. I'm happy to answer your question.